Welcome to this presentation on habitats and niches as they apply to turfgrass species. The term habitat and niche are in many ways similar to the point that I sometimes find them confusing. However, they are different by definition. A habitat is a place where species live. The features that characterize a habitat are often referred to as physical. Aspects like elevation, slope direction, the soil type, and water availability would just be a few. The second aspect is biotic and refers to all species present. Examples of habitats include lakes, stream banks, marshes, a backyard, an athletic field, and for example we will use a putting green. The impact of physical changes, even on a putting green, are evident here. This is a poa annua green that has come out of winter, and the dark green areas where snow cover remain longer than the higher areas which are more wind-burned or desiccated. Even a habitat like a putting green can have variation within it. A niche refers to the role a species has in the environment, where the species can grow, develop, and reproduce, and is defined by a range of conditions and resources. Prior to the 1950s, niche was often a nebulous term that was not very easily quantifiable. However, in the 1950s, an ecologist by the name of George Evelyn Hutchinson, who by some is referred to as the father of modern ecology, quantified what a niche was based on conditions and resources. He described a niche something like n-dimensional hyperspace. Shown here is a two-dimensional niche as defined by sunlight and moisture. Here is a three-dimensional niche with temperature added to further define the niche. And now we add a number of conditions and resources, and the niche becomes n-dimensional. Thus, for a space to be a habitat, it must provide the proper range of resources and conditions in each dimension for all the n dimensions, and provide, again, there be adequate space. Now, trying to visualize an n-dimensional hyperspace niche is pretty mind-blowing. Thus, we use two-dimensional models to describe species in a competitive sense. So in this case, we have chosen the species creeping bentgrass that is found on our putting green habitat and defined it by sunlight and moisture. Hutchinson's quantification of niche allows us to look at competition between species. So drawn here is a two-dimensional niche for poa annua. If we look at both creeping bentgrass and poa annua regarding light, poa annua outcompetes creeping bentgrass, as shown here. The white line delineates between the shaded part of the green and the part that is in full sunlight. Notice the number of yellow spots or patches in the shaded area. These patches are poa annua. Notice to the right of the line the lack of these little light green spots, and actually lack of poa annua in the creeping bentgrass turf. Generally speaking, creeping bentgrass does not require as much water as poa annua. Where poa annua does well, or possibly outcompetes creeping bentgrass, is in wet, compacted areas. Returning to our two-dimensional creeping bentgrass niche, we can draw the box representing creeping bentgrass. The entire area of the box where the creeping bentgrass plant is shown is referred to as the fundamental niche. It is this full range of conditions and resources that is in this case creeping bentgrass can use. Now we introduce poa annua as a competitor with its corresponding niche. We see there is some overlap. This box represents where the poa annua would exist. The creeping bentgrass niche becomes much smaller, and what is left, as denoted by the red areas, is called the realized niche. This is where creeping bentgrass would be restricted to with regard to its niche in face of competition. This is also known as the realized niche. One of the principles of niche competition is known as the Gauss principle, or mainly known as the competitive exclusion principle, which was proposed in the 1930s by the Russian ecologist, which states that two species competing for the same resources cannot coexist if other ecological factors are constant. If one species has only the slightest edge over another, then the one with the advantage will dominate and the other one will be driven to extinction. Pretty brutal. Returning to our example and to the creeping bent grass niche, in the face of competition of Poa annua under conditions and resources that might slightly favor Poa annua will predominate and drive creeping bent grass away. There are many examples of this normally found on putting greens established to creeping bent grass, and then within a few years becomes Poa annua. However, we do see species coexisting. This striking picture is of a fluorescent plankton. Plankton is found in our oceans, and although the species are similar, a diverse group of these species exist. In turf we can see this too, again using our creeping bent grass Poa annua example. This is an old creeping bent green coexisting with Poa annua, at least for the moment. How can species coexist if they share similar niches? There could be several reasons. One is resource partitioning. In this case, there is a differential competition for resources between the species. In grass systems, this may be a little more difficult to work with because plants, unlike animals, are not mobile. But one example is winter overseeding. We have two different grass species, Bermuda grass, a warm season turf grass, and perennial ryegrass, a cool season turf grass. In this case, as fall approaches, Bermuda grass enters dormancy, and perennial ryegrass is seeded into the turf, as shown here. The dark green color is from the perennial ryegrass, and the off-colored turf is Bermuda grass. In this case, perennial ryegrass is utilizing the resources for growth, while Bermuda grass is dormant. Once spring comes and temperatures begin to rise, perennial ryegrass will die due to changes occurring due to susceptibility to heat, while the Bermuda grass breaks dormancy and begins active growth under the warmer and more intensive light conditions. In this situation, fluctuations in species populations occur. During the fall through springtime, Poa annua is actively growing and thriving in comparison to creeping bent grass on this screen. But as summer heat stress periods begin to occur, creeping bent grass compared to Poa annua is much healthier and becomes more aggressive, relatively speaking. The seasonal fluctuations can also occur. Partitioning may also occur with differential root depth. Poa annua is more competitive under wet conditions, while creeping bent grass is during dry periods. On the left, annual bluegrass shows its shallow root system. Creeping bent grass on the right has a much deeper root system, which should be able to tap water resources further down in the soil profile. This ends this presentation on habitats and niches.